Let us now perform the simulation. So we have the octree mesh that we have created, and now we will use this mesh and then perform the simulation using this component Amphyon simulation. So as we can see, we should also input the material here. So we have a component that has a preset of material library. So we can select the material from there, which is this one, Amphyon preset material, and it has got some materials and with the properties already defined. So if you want to define any other material, we can use this component Amphyon material and then define the properties here. So for this example, let's go with this material now and perform the simulation. So here we see there are also a couple of other parameters or the inputs that we should understand now. So let's go and have a look at them. So the first one is the solver tolerance. That means as we increase the value more towards 1, the results will be more accurate, which also means that it increases the computation time. And here we can select between GPU and CPU, and here we have some other settings. So here we can select how the part will be removed from the base plate, either in the symmetric or in a directed way. So here we can define the angle in decrease at which the part will be removed. And here we have the heat treatment settings, whether we choose not to perform the heat treatment or perform it, and also at what stage. So before releasing from the base plate, or after release, or even after the support removal. So if we select the heat treatment for one of these stages, for example, let's select after support removal, and here we can select the model, heat treatment model. So here we can define the properties during the heat treatment, that is Young's modulus and the stress. If you are not aware of this properties, we can select this model stress to 0, which assumes that all the stresses are relieved during the heat treatment process. That means it will not have any effect on the deflections of the part. So let's run the simulation now. We can see that the simulation is now completed. So now we will have a look at the results. In order to understand more about the component and the background what it runs, so we can right click on the component and look at the help, which explains in detail about how the component runs. So now we will make use of the simulation result and then look at the results. So now we can use the simulation results to view the displacements. So we can connect the simulation result here and then use this component called Amphyon result view. So this one, and then here we will see the result. So here we can see the result of the last increment, and here we can change the visualization in order to have a better look. And so each of these increments implies each stage during the build process. So if we go towards increase the increments now, so starting from 0 and as we go, so here you can see the build process in each of these increments. And if you go to the final increment, it also has the support removal. So here we can also select between different results to look at. So we can select only displacement Z, or we can have a look at the stresses and select different quantities. So here we can also change the scale of the displacement in order to magnify in the viewer. So we can change the displacement scale, and here we can observe that the part is distorted towards the upward direction. So now we will see how to compensate these distortions. So we can make use of the simulation result now and perform the pre-deformation using this component. So here we have to input the mesh part and the supports here, and also the type of support again. So let's turn this off for now, refining the part. So here we can directly select this input that we created to define the support type for the meshing, and then here we will input the mesh that is the part and the supports. So now it will create the pre-deformed part in order to compensate the distortions. So here we can see this is the pre-deformed part that is being created to compensate the distortions. So here we can select to refine the part, so that refines the part about the region where there are distortions. So now we can see that the part is refined in the regions where there were large distortions, and here we will see only the deformed part now, and change the visualization like this. So now we can see that the part is compensated like this in order to take care of the distortions. So we can increase the deformation factor in order to have a better look, but this is the deformed part or the pre-compensated part. We can also have a look at the supports like this. So now we can export this part to our working directory as an STL file. So we can use this component export geometry and export it as an STL file, and here we can say it's exported successfully. So this is the end of this course, AM process simulation using Amphyon, and here we have learned how to create the workflow. So now you can make use of this workflow in order to perform process simulation for any other part. I hope you enjoyed this course.